Hey everybody, Mr. Covey here. Today we are going to talk about 8 super important theorems about addition and subtraction of angles and segments. So let's get into it. The first one here says if the same segment is added to two congruent segments, then the sums are congruent. So if we look at this picture here, we have that RS is congruent to PQ, and we are going to add QR to both of them, and the result will be two congruent segments. So what we can say is that our conclusion is that PR is congruent to QS. And visually that makes sense. This same idea applies to angles. So if we have that BAC is congruent to DAE, and we add this blue angle CAD to both of them, what we can conclude is that that angle and that angle are congruent. So our conclusion would be angle DAD is congruent to angle CAE. Two more we have here. This next one says if congruent segments are added to congruent segments, then the sums are congruent. So if we look at this picture here, KR is congruent to SO, RM is congruent to PS. What we can conclude using this new theorem is that KM is congruent to PO. Those two segments are congruent. Same thing works with angles. We have two congruent angles. We have two other congruent angles. If we add them together, the resulting angles are congruent. So our conclusion here would be that angle TWX is congruent to angle TXW. And again, visually, this makes sense. All right, next one here. And please note that all of these are going to apply for segments and angles, all of the theorems we are looking at today. This one says if the same segment is subtracted from two congruent segments, then the differences are congruent. So we have that AC is congruent to BD. We are going to take away the same segment from both of them. We're going to take away BC from both of them. What we are left with is our conclusion using this new theorem is that segment AB is congruent to segment CD. With angles, we have that the two green angles are congruent. We are going to subtract the red angle from both of them, and we are left with the two blue angles being congruent. So our conclusion using this new theorem with angles is that angle EFG is congruent to angle HFJ. Okay, last pair here says if congruent segments are subtracted from congruent segments, then the differences are congruent. So let's look at that. We have that KO is congruent to KP. We have that RP is congruent to NO. We are going to take the blue and subtract the green, since the blues are the same and the greens are the same. What we're left with in red must be the same. So our conclusion here is that segment KN is congruent to segment KR. Let's take a look at it with angles. We have that the blue angles are congruent. We have that the green angles are congruent. If you take the blue angle and subtract the green angles, you are left with these little red angles, and our conclusion is that those red angles are congruent. So we can conclude that angle, WTE is congruent to angle SET. Okay, time to look at some proofs using these new theorems. So here's our next proof. Let's start by labeling the diagram. So TV is perpendicular to VX, meaning that's a right angle, and WV is perpendicular to VY, meaning that is a right angle. Labeled our diagram, always a good place to start. Let's get into our proof. So that we have those pairs of perpendicular segments, that information is given to us. Okay, we have that they're perpendicular. Now we want to say that they are right angles. Our reason is if two segments are perpendicular, then they form right angles. Okay, so now we have that TVX and WVY are right angles. We want to say that they are congruent. Well, two angles are right angles, they are congruent. That is our reason. If two angles are right angles, then they are congruent. So we've now shown that our two right angles are congruent. And this next step's kind of weird. It says that angle 2 is congruent to angle 2. Well, it's the same angle. Of course it's congruent. There is a name for that. Whenever you need to use that idea in a proof, it has a name. It is called the reflexive property. You need to state that that is what you are using to make that statement. I think about it like a mirror. You look in a mirror, you see yourself, you see your reflection. You're setting something equal to itself. The reason that's true is because of the reflexive property. And our last step here, we need to use one of our new theorems. So we are taking two congruent angles and we are subtracting the same angle from both of them and saying the resulting difference angles are congruent. So let's say that. So if the same angle is subtracted from congruent angles, then the difference is congruent. We should also note what two previous statements we are using. We are using statements 4 and 3. So we should say that there. Okay. For this next proof, I'd like to do a flowchart proof. So let's start by marking our diagram. We have that BAC is congruent to GAF. And we have that AD and AE trisect CAF, meaning these three little angles there will be congruent. And we want to show that BAD is congruent to GAE. So let's start our proof here. Let's start with our rays trisecting our angle. So we have that ray AD and ray AE trisect angle CAF. Let's put that in a bubble. And that is given to us. From there, we can conclude that all three of those red angles are congruent. So angle CAD is congruent to angle DAE, which is congruent to angle CAF. Excuse me, I said CAF, I meant EAF, that other small red angle. And for our reason, we can be a little bit, use a little shorthand here. We can say two rays trisect, then divide an angle into 3 congruent angles. Now you'll notice we haven't used that other given information from up top, and that's because we haven't needed it yet in the proof. Now we need it, so now we state it. So angle BAC is congruent to angle GAF. That is given to us. And the reason we stated it now is because these two statements together allow us to make our conclusion. So our conclusion is that angle BAD is congruent to angle GAE. And we are using one of our new theorems here. We are using the fact that if congruent angles are added to congruent angles, then the sums are congruent. The nice thing about doing a flowchart proof like this is that you don't need to state which two previous statements you're relying on, because it's very clear that those two are coming together to let you reach that conclusion. Okay, we're going to now do a 2-column proof. Let's start by labeling our diagram. So we are given that NR is congruent to PT. We are also given that MN is congruent to TV, and we want to show that MP is congruent to RV. So this first piece of information that we are using, that first statement, is given. Next, we have that PR is congruent to PR. Remember, we call that the reflexive property. Next, we're reaching the conclusion that NP is congruent to RT. That's because we are taking away segment PR from NR and PT. And so this is one of our new theorems, and we should say that. So if the same segment is subtracted from congruent segments, then the differences are congruent. We should, in parentheses, note statements 2 and 1, because those are the two statements we are relying on. Now comes into play that other information that was given to us. We brought it up now because this is where we need it in the proof. And now we are ready to reach our conclusion that MP is congruent to RV. And we are using the fact that if congruent segments are added to congruent segments, then the sums are congruent. And those congruent segments that we are added, we got from statements 4 and statements 3, so we should say that in parentheses there. This last proof I want you to do as a flowchart proof. Do it on your own and bring it into class, and we will discuss it. And that concludes video 2.5.